Hello, my name is Keshwani. It's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 167, problem number 112. Today is our lesson number 119. Let's take a look at problem 112. It says that we have a normal distribution. Actually, they do not use the word normal distribution, do they? A certain characteristics in a large population has a distribution that is symmetric about the mean. If 68% of the distribution lies within one standard deviation of the mean, what percentage of the distribution is less than mean plus the standard deviation? The question simply is here, what percentage of the distribution lies between mean and the first standard deviation. And the distribution that they're talking about, this looks something like this. This problem deals with the concept of what is known as a normal distribution. And if you're not familiar with the concept of normal distribution, then it's difficult actually to understand what they're talking about and what they're asking here. Normal distribution looks something like this. Here's your mean, the peak is the mean. And the characteristics of normal distribution is that once you go from the mean in either directions, this is the mean plus the first standard deviation, this is the mean minus the first standard deviation. When you are in this range, we capture 34% of the population on either side. Well, let's finish it up since I started this thing. If you were to go one more standard deviation, mean minus 2 standard deviation and mean plus 2 standard deviation, it's good to know. Even though this question does not ask for it, it's good to know. You will end up capturing another 14%. Now, 34% plus a 14%, 34 plus 14 is 48, which means only 2% of the observations are going to lie above the 2 standard deviation. Only 2% in the tail. 2% in the tail. And again, similarly, you will have 2% of the observation in the tail. The question is, how many observations are going to lie below the first standard deviation? The first standard deviation is right here. Well, first of all, this is the middle part. This is the middle part, which means, if it's the middle part, which means 50% of the observations are to the left of it. Of the observations are to the left of it. So 50% are to the left of the mean, and another 34% lie. Another 34% lie between the mean and the first standard deviation. Another 34% right here. Let's do it in a different color. So that's it, that's our answer. Question is, what percentage of the observations are going to lie below mean plus the standard deviation? The answer is, the 34% are here, and the remaining 50% are here. 50 plus 34 is 84%. The answer is 34 plus 50. 84% of observations are going to lie below the first standard deviation. Now, if you're still having trouble with this concept, I'm not going to go into too much detail right now because I just want to finish the problem here. But if you're still having trouble with it, go to the search area of the YouTube, type in my name, and just type in this tag here, normal distribution. And you will find some videos that I did for the GRE. I know that we are not here for GRE, we are for GMAT, but I did for GRE some videos where I went in depth into covering this concept of normal distribution, and you might find it helpful if you're having trouble with it. But other than that, we are done. It's a pretty straightforward question. The question was what percentage of the observations are going to lie below the first standard deviation? The answer is 50% lie to the left of the mean, and another 34% is going to lie between the mean and the first standard deviation. Therefore, altogether, 84% of observations lie below the first standard deviation. The answer is D. Let's do the next one, shall we? Let's do the next problem. Problem number 13. In 113 we are told that the ratio of Republican to Democrat, let's call them R and D, is 3 to 5. Then we are told, then the Republican number goes up by 600 and the number of Democrat goes up by 500. And as a result, the new ratio is 4 to 5. The new ratio is 4 to 5. The question simply is, how many more Democrats compared to Republican after the change? How many more Democrat compared to Republican? This is the part. This is where we have to pay attention after the change. Let's find out, shall we? Let's find out. So the new ratio is 4 to 5. The new ratio is based on the fact that we started out with R number of Republican. We started out with R number of Republican, and then the number went up by 600. So the new number of Republican is R plus 600. We started out with D number of Democrat, and then that number went up by 500. And that equals, the new ratio equals 4 to 5. So that's our equation we're going to work with. That's our first equation. Or that's actually our second equation. The first equation is sitting right here. This part tells us, if you were to cross multiply, it tells us that 3 times Democrat equals 5 times R. This is our equation 1. This is our equation 2. We're going to work with equation 1 and equation 2, and we should have no problem find the numerical values of the new number of Democrats and the new number of Republicans. And once we have that, we just take the difference. I need the room, so I'm going to have to erase most of this stuff. So, continue with this one here. Cross multiply this equation here. Cross multiply here. This is D plus 500 times 4. D plus 500 times 4 equals R plus 600 times 5. R plus 600 times 5, which comes from the second equation. I'm going to get rid of it now. Let's open the parenthesis. D times 4 is 4D. 4 times 500 is 2000. 5 times R is 5R. And 5 times 6 is 3000. Now we already know what 5R equals to. 5R equals to 3D. We're going to put it here. 5R equals 3D from here. So let's put 3D here plus 3000. Subtract 3D from both sides. Subtract 3Ds from both sides and we end up with D equals 3000 minus 2000, which is 1000. Now what does D represent? D represents the odd number of Democrat. You have to keep that in mind. You have to know your symbols. Therefore the new number, of Democrat equals 1000 that we started out with, plus an increase of 500. Looks like Democrat went up by 500. So that's 1500. What is the number of Republican? We have to figure out the number of Republican now. Democrat equals 1000 right here. We can put it in this equation here and find out the number of Republican. So I'm going to erase the part so that I can have the room. We should do it here. We know that 5 times R equals 3 times D. We just found out that D equals 1000. So 3 times 1000 equals 5 times R. Therefore R equals over 5. 5000 divided by 5, 100 divided by 5 is 20. 1000 divided by 5, therefore it's going to be 200. It is 600. So the old, therefore R equals 600, which is the initial number. Therefore the new number of Republican equals 600 plus the fact that the Republicans went up by 600. You see, this is where you have to pay attention. 1200. That's it, we're done. The question is, how many more? Let's read the question how it's written. Number 113. After the registration, after these changes, there are how many more voters in the district registered as Democrats? There are how many more Democrats compared to Republicans after the change? Well, the new number of Democrats is 1500. The new number of Republicans is 1200. How many more? The answer is there are 300 more Democrats after the change. Well, after the change. That's delta for change. I'm being lazy here. After the change. That's it. The answer is there are 300 more Democrats. And that is answer choice B. Answer choice B. And that's all. That's it, we're done. I'll see you tomorrow, okay? Bye now.